an informative essay or speech on concrete and the uses and types in the industry today. Okay, so we're going to go over the simple composition of concrete. All types of concrete require Portland cement. Portland cement is a finer, what's the word? A finer aggregate. We'll go over aggregates here in a minute. And it's used to mix and bond all the aggregates and other ingredients together. Okay, so we want aggregates. Aggregates are just crushed up rock, and it helps hold, just like Portland cement, it helps hold the concrete together, and also it adds strength. That's its main purpose in the mixture, is to add strength and to perform its job for these heavy loads. It's going to contain. Batch plants. Batch plant is where you can get your concrete in large sums. It's in the sense you mix quickcrete in a wheelbarrow. You get large sums of concrete for large heavy jobs off of a batch plant. Batch plants can be set up on large job sites to lessen the amount of time of the project and also save costs in the long run. It seems like it would be a more expensive option at first, but if you're pouring, so many tons of concrete, it's going to be more beneficial to set up a small batch plant on site. The mixture process is just like we said in a wheelbarrow. It's going to go in and there's a process operator or an operator that's going to operate the plant, and it's going to go from one. There's different types of concrete made through the plant. There's different admixtures, so you can have high tensile strength concrete, or you can have high water content, all these different sorts of concrete. And they're going to go through and add these ingredients together, piece by piece, and all the way to the truck to be delivered to the job site. Okay, ASTM standard types of Portland cement. Type 1 cement is your normal cement concrete mixture you're going to use to pour a slab for an office building, depending on the size. Sidewalks, just typical concrete. Type 3, these are just some examples. There's 5 different types in the ASTM standard. Type 3 is high early strength, so that's going to be for a highway. So you're going to have, if you're closing down a highway for repairs, a highway is going to need this high early strength concrete to ensure that its curing time is a week to a week and a half, as opposed to 28 days of the type 1 normal concrete. And then we have permeable concrete. I have a particular interest in permeable concrete. It's very porous. And this is go back to this high early strength concrete. This is a compression test performed, and once the concrete dries and it's cured, they perform these compression tests to be sure that it is within standard and it's safe for people to use and travel on. Okay, and this is the permeable concrete. You see the water's traveling through the sample there. Like I said, it's very porous, and it has it's similar strength to type 1. There's a video that I can show you guys after. We're not going to go through the time to do that right now. It can take thousands of gallons of water. So if you have a bunch of rain, it's good for parking lots and sorts like that. And the water literally just disappears. It drains through the concrete, and it's pretty impressive. I find a very big interest in it. Okay, placement methods. A placement method would be considered precast concrete, as shown in the picture here. Precast concrete is like in a fab shop. They prefabricate I-beams and stuff like that. Precast concrete is going to be cast in place within a facility to the spec or the code that you want, with the correct type, and then it's going to be shipped. It's also going to save you time on site. So it's already, you can start your project before the project is actually started in the field. So that 28 days you normally have to wait for the concrete to cure, it's already been cured, and you can move on to the next step without having to wait that time. In situ concrete, so it's in place, you're doing it right then and there, would be like a concrete slab. This is the formwork for a bridge, and this formwork is in situ concrete, but it started at the bottom here, and then the formwork actually jacks itself up. You jack it up, and so you can make columns in place in situ. Pouring practices. Formwork for these pouring practices. Proper formwork is going to be your biggest and most expensive commodity in pouring a slab. The formwork is going to keep the concrete in place, of course, and then also correct bracing for that formwork. All of that weight is pressing against this formwork, this lumber, and you have to have correct bracing for it to be able to withstand those high capacities. Monolithic pouring. So monolithic pouring is you're going to pour once. You're not going to pour something and wait and then come back and pour over it again. So a slab with monolithic pouring. So if you don't pour quick enough, you get something called cold joints. A cold joint, I believe we talk about it later in the slide. Cold joints are when the concrete has time to dry and then you pour over it again, and that's going to take away from the strength and durability of your pour. And you also have stress joints that are designed, expansion joints that are designed to go inside of your concrete, which is normally a piece of 1x1 lumber that goes in between, and it's for when the heat expands the concrete and so it doesn't crack. But typically monolithic pouring is going to give you the most strength and durability in terms of slab, and depending on the size. It's all depending on variables of that project. Reinforcement materials are going to be rebar, typically. So that's just this welded wire that is put inside to again add to the strength of those aggregates. And then once you pour your concrete, you're going to vibrate. You're going to use a handheld vibrator, and you're going to go down in the concrete with it, and that's going to make sure it all settles and there's no honeycombing on the next to the formwork. That's where the concrete doesn't fit flush and smoothly on the formwork due to air pockets. It's going to get rid of those air pockets. But you don't want to, when you're using the vibrating machine, you don't want to hit the rebar with it, because that's going to cause the aggregate to go away from the rebar, and that's going to cause a weak spot within that section. And then we're going to conclude with usage today. So concrete usage today, you see China is up here at the top. I can't read you the number, but this is just for a visual on how much concrete China uses compared to the U.S. is third on the list. So, and, you can pretty much go anywhere and stand anywhere on the earth and see concrete from where you're standing, nearly everywhere. And especially in the United States, and China's producing all of this concrete. Most concrete is used here. You see here the ready mix is 70% of what is consumed in the U.S. Concrete products that are made, so prefab products that you buy in the store, are going to include 13%. Contractors, independent contractors are going to use 6%, and then building material dealers 3%, and then other 3%. And then here's the citations. This is a book we use in our heavy construction materials and methods class by William Spencer. Permeable concrete, that's the video that I have to show at the end, and that's just a good visual aid and back up to what we talked about in that slide. and then cement and concrete by Nicholson. That's where I got those last two charts, and that concludes the presentation. Oh man, how much time we do?
9.5. Well, I got almost 10 minutes.
Good deal. Any questions?
Is that a battery plant right there?